So actually, while talking regarding the science as well as engineering, there is a total relationship between both of this. We can see everything starts with the foundation of basic sciences like mathematics, physics, chemistry, then biology. These are the basic sciences coming. After that, when we are going for an application, that is combination of sciences are coming. Physics do not exist without mathematics, and there is a physics in mathematics also. But when we are interlinking all together, there comes a common mathematics in physics, chemistry, or biology. Yeah, so we will think that where it comes in biology or in any other thing, there also a repetition, a pattern is there, a structure is there, everything, a geometry is there, everything will be evaluated using mathematics. So whatever or what all things we are undergoing in our day-to-day life, we can link it with mathematics. So when it comes to engineering, it's like a combination of mathematics and physics. Like we know that all sort of applications happening in the recent days, especially in different domains of technology like communication, automobile, construction, civil engineering, whatever it may be, it's an application of this basic sciences only. Like in engineering, what we are planning is that we are creating something, but science but with the knowledge of that basic science or using that abstract knowledge of that science, we are building something and going for the application. So I had the previous speaker who had given a good presentation over the material engineering, like the properties of different materials, everything. uh, it's a like a resemblance of the real science along with engineering, how the application coming into mechanical engineering. So in the current scenario, we have to see that we are going for blended technology. So what is blended technology in the terms? Like the basic core branches like mechanical, civil, and electrical has to undergo a change or a transformation. Like we know that in current scenario, we are not having a pure core electrical or a mechanical product nowadays. If you are going for automobile industry, now we can see the electrification of vehicles are happening. So where is the engine? There is no engine. Everything is motor. So no one needs to change the oil or there is no like the mechanical structures are coming. More part will be given by the electrical side. The cell structures are going to play a vital role. Then the tires will be there. No sound will be generated. So, but altogether it's a mechanical structure only, but inbuilt with some electrical assistance. So that is the evolution of the electric vehicles in the current years. When we are going for the buildings, the construction site, it is not the pure core civil engineering. We are more focused on the safety measures, like we are having a lot of sensors for identifying or for providing better safety, as well as we are having the robo parking, like not like the previous one. We are going for the vertical structures rather than the horizontal. We are considering the space optimization. So it is going for a hybrid mode, like we need to explore ourselves. And when it comes to the other sides of engineering, like whether it may be the new evolving technology like biotechnology or biomedical also, we see that everything is linked with the computer science. So now the whole world is going beyond this computer science stream. But actually, what about the other streams? I think all other streams are now linked with computer science. Nothing is possible without a computer science. Now, while servicing a vehicle, also they are connecting the laptop assisted by the software to detect any fault with the vehicle because that embedded system or the chip will be deciding or giving the sensors that any problem is there. So it's like a blended technology, like electronics, electrical, computer science, along with the other engineering is coming into the picture. And the main challenge we are going to face is the other thing is that waste management. Now the previous speaker has already mentioned a lot of materials. What about the plastics generated in the world? That is a big issue which we need to answer. Now we are all focused about the green environment or the green revolution. Ideally, the world is totally getting polluted with all the toxics coming out of the industry or the chemicals as well as the smokes generated by all these things. And what is the real process of regenerating the waste or like we need to recycle it to produce something which is beneficial for the society. So I think in the case of plastics now, there are a lot of technology undergoing, like it can be used for the roads as well as for building tile blocks and a lot of materials like the combination of material science. It is on high demand in the coming areas, in the coming years, and it can also be blended with a lot of other technology. And when on a future forecasting the future, what is going to happen in the application side in this field? Like we know that the robotics, that is the AI will be playing a vital role. Now the camera is also assisted with artificial intelligence technology for more resolution and clarity. Similarly, a lot of jobs will be taken away by AI. So what we need to do is that AI is nothing but the underlying concept is mathematics. So everywhere that basic science, that mathematics will not be changing. Like when we are seeing the pattern, like it is a repetitive pattern. You take the example of a tree leaf. The new leaves are coming. It's having the same pattern. Or take our own cells, the structure of our cells. So that is a fractal actually. That is a repetitive, iterative process. This iteration is playing a vital role in mathematics, and we are using that iteration when we are coming for continuous domain as well as on discrete part. That integration as well as summation is coming. And with that instance, we can relate it with the iterative process. In that iterative process, till the limit, that process is continuing. So everything, the coding or whatever changes we are making is based on an algorithm or a formula. Ultimately, if some changes or the concept in that formulation is changing, new new computational efficiency can be created. That's what I feel, because now everything is programmed and without coding nothing can be done. And the crust of the coding part is mathematics, like the design part as well as the main algorithm playing the vital role. We know that now we are connected to the laptop or through the communication. The communication is also having a mathematics involved, like the frequency is coming and time is coming. So if is direct is equal to 1 by t, then that whenever there is a change in time, it is implicated in the frequency also. That is the communication. And we know that the spectrum allocation is coming. For example, while communication is being happened, we are using a particular band of frequency, and there are a lot of technology and a lot of primary users are paying for that spectrum, and we are having the secondary users for the free usage of spectrum coming for medical and laboratory uses or the technical side. So there are a lot of algorithms related with spectrum sensing also, that is also having a wide application. So this subject, that is engineering technology and basic science, is the scope is beyond limitations. The limit tends to infinity, because the subject is iterative. New technologies has to come, because when we are drawing a union of engineering, science, and technology, there is a common part. That is a part for humans for better living. So I think science, technology, and engineering is standing here for a better living. So I'm so thankful to share screen with this conference, and my special regards to Professor Senai from Turkey. So thank you for giving this opportunity. I am very much happy to be associated with this platform. The thing is that today I was quite busy, so I was not able to share the slides. Actually, if I was planning, it will be better. So thank you, and my best regards to all the speakers and eminent professors being present here. Thank you.
Thank you so much for making an